Welcome. This will be our last lesson on trigonometry, which I'm sure many of you will be very happy about. We're going to do the very last one on HH, number 6, solving right triangles. All that means is you're going to look for or find all the missing values of a given right triangle. So I'm just going to start doing some, and so hopefully you'll be able to follow along with the process, and it shouldn't really hopefully be too difficult. Again, I hope you remember that the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. By the way, this little weird circle with a slash through it is just the Greek letter theta. And it's just a variable like A or B or C. But they use theta in order to represent an unknown angle or an angle. So let's look at some of the homework that we're going to be given. Here's a triangle. It has 3 pieces of information. For instance, we know where the right angle is. We know where this is a 24-degree angle, and we know this length of this side here is 5. It wants to know the other 3 missing parts. In other words, what this angle measure is, what the length of this side is, and what the length of this side is. So what I would recommend doing is you have a piece of paper, and you just, for each problem, just quickly draw a little diagram and fill in the missing parts. So the easiest one initially is going to be this missing angle here, because all 3 angles must add up to 180. Or since this one's a 90-degree angle, these 2 must add up to 90. So I just do 90 minus the 24. And you're more than welcome to use a calculator for these problems. 90 minus 24 gives us an angle measure of 66 for this angle measure. We also know this side length, that's 5. Okay, we don't know either of these, so I'm just going to label them X and Y. Doesn't matter what we label them, I'm just labeling them some unknown variable. And now I'm going to look at my trig functions and try to solve for these. So for instance, if I look at the angle 24, the sine would be the opposite side over the hypotenuse. So I could write the sine of 24 equals x over 5. Now, I'm just going to get the x by itself by multiplying both sides by 5, and I find out that x is going to equal 5 times the sine of 24. And so I can do that with my calculator. On my calculator, I just do 5 times the sine of 24. And again, by the way, make sure, I'm going to go to mode for just a minute, make sure your calculator's in degree mode, right? So that 5 times the sine of 24 is 2.03. Now, if you look over at the problem, it says round your answers to the nearest tenth. So since it's a 2.03, it's 2.0. So x is 2, basically. So I'm going to write this as a 2 equals 2. Now, I can solve for y in one of 2 ways. I can do Pythagorean's theorem, or I can use another trig function. I'm going to use Pythagorean's theorem. Since this is the hypotenuse, I'm going to do 5 squared minus 2 squared, and then square root that number to get y. So I'm going to do 5 squared minus 2 squared. I'm going to get this 21, but now I'm going to square root that. The square root, and that's my square root button. If you can, it's hard to see on my calculator. It's this blue square root button right there, but I'm going to square root the 21. And I get 4.58. Now again, it asks us to round it to the nearest tenth, so I'm going to do 4.9. Come out here and write 4.9. Now I have my 3 missing values. I'm going to type them in. Be very careful that you answer the right one. I mean, you put the answers in the right spot. HI is this side over here. That was our x value. So, and our x value was 2. So I'll type in a 2 there. Our HJ was this side over here, which is the 4.9. And I type in 4.9. And then my I value is this angle here that was missing, which is 66 degrees. And I submit. Got to be joking me. Oh, look at that. I typed in 4.9, wrote down 4.9, but look, it's not 4.9, it's 4.6. If I round this to one decimal place, it's 4.6. So by all means, make sure you keep track of your numbers. It's so simple to make an easy mistake. It's not iExcel's fault. And I know we get mad at iExcel because it drops us when we make mistakes, but we need to learn to be very careful in our math and in writing things down. So I got it. I know what my mistake was. Let's do another one. So again, the first thing I'm going to do is write down a reference triangle. I'll write down that triangle, putting in the things I know. I know this is 49 degrees, and I know this side length is 4. Now I'm going to find all the other missing sides. First of all, this angle is going to be fairly simple because, again, if this is 90, these two must add up to 90. So I'm going to take 90 minus off this 49 to find that other angle. Find out that this angle measures 41. Now I'm going to start using my trig functions, but I'm going to label this x and this y. So I'm going to say that the sine of 49 degrees is equal to the opposite, which is x, over the hypotenuse. Here's the right angle, so the hypotenuse is this, 4, or times both sides by 4 now, and I get 4 times the sine of 49 degrees is equal to x, right? So on my calculator, I just go 4 sine of 49 degrees, and I get 3.01. So this x is 3.0 if I round it to the one decimal place. Now again, I'm going to use Pythagorean's theorem to solve for this missing y value. So since this is the hypotenuse, I'm going to go 4 squared minus this leg squared, 3 squared, equals this y squared. So I got 16, because that's 4 squared, minus 3 squared is 9, gives me 7, and then I square root that answer, or square root 7, because it's just easy to type in 7, and I get 2.64. Now I'm going to be very careful here. 6.4, that's going to be a 6, 2.6. So now I'm going to come over here. IJ, that's that top side, was 3. HJ, that's this side here. HJ is 2.6. And again, I'm being very careful this time. And the measure of angle I was 41 degrees. Type in 41 degrees, and I hit submit. And this time, great, I did good. So again, this process, let's do it another time. So what I'm going to do is I'm going to, again, make sure I remember these 3 trig functions. I'm going to draw my triangle, mark my right angle, label the 2 parts that it gives me. This is 22 degrees. This is 8 in length. To find this missing angle, these two must add up to 90, since this one's 90. So 90 minus 22, 90 minus 22 gives me 68. So this angle measures 68. Now again, I'm just going to use one of the trig functions. And by the way, if the first trig function you pick doesn't work, then try another one. So in other words, if you tried sine and it didn't use this 8, then I would use cosine or tangent. Just be careful. Maybe you want to actually label these sides. In other words, if I'm referencing this angle 22, then this side would be the opposite. This side would be the adjacent. This side, which is across from the right angle, is my hypotenuse. So when I take the sine of 22 degrees, it equals my opposite, which I'm going to say is x, some unknown x, over the hypotenuse, which is 8. So that works for me, the sine. A lot of times the sine will work, but it doesn't always. Sometimes you might have to try the cosine or tangent. You could always use the other angle too. I didn't have to use 22. I could have used 68, and then that would have been the opposite and the adjacent. Not to confuse you, just remember it depends on which angle you're using. times both sides by 8 to get the x by itself. So I know x is equal to 8 times the sine of 22. So on my calculator, I'm just going to do 8 times the sine of 22. I find out x is 2.99. Again, if I round to the nearest 1 decimal place, that's going to be 3. So this side here is 3. Now I'm going to use Pythagorean's theorem to solve for this. Since this is the hypotenuse, it's going to be 8 squared minus hypotenuse minus the leg squared equals the other side squared. I'll just label that y for now. So 8 squared is 64. Minus off 3 squared, which is 9. I get 55 is equal to y squared. So I got to remember to square root that. So I square root 55. And I find out that y is equal to 7.41. Again, if I round it to 1 decimal place, it's 7.4. Now I come over here, and now again, I'm very, very careful in making sure I put the numbers in the right spot. UW. UW is this one over here, which is this side, which is 3. UV. UV obviously is going to be this top side then, which is 7.4, and I've looked at my number a couple times to make sure I'm not typing it in wrong like I did on the very first problem, 7.4, and then we already found that unknown angle here, angle W, which is 90 minus 22, or 68. And then I hit submit. Again, if you have any questions on how to do this, the process is just very similar to this. Please contact me via email or log on at 1 o'clock, and I will help you work your calculator and to get this process of finding all the missing parts of right triangles.